Okay. As I said, today we are going to talk about the phase lag compensator. Last time we started it, but let's do it again. Okay. Remember the format of the phase lag compensator is this one. A alpha 1 plus tau s and 1 over alpha tau s, where we have in here the location of the pole is going to be nearer to the j omega axis, which means that, in the system in here, we are going to, the net phase which we are going to put in the system is going to be negative. So we are taking phase from the system. This is where the phase lag, if you remember, we have said phase lag, it means that, the phase of the denominator or the angle of the denominator greater than the angle of the numerator. So the net effect, if I add this one to the system, the phase is going to be negative. And remember, this is basically the body plot for the lag compensator.
دكتور
تفضل.
increase the phase margin or not?
كيف؟
Will this decrease the phase margin?
No. This will, yes, it will, but you are absolutely right. I mean, good observation. Okay, but wait, look, how do we do it? Okay, let's look in here. Okay, let's look into this one. We will come to your point. Okay, in a moment. Okay, I will tell you what to do. Yes, if we do it in the same way, it will definitely reduce the phase margin. But we are going to do it slightly different from the lead compensator. Now tell me, at high frequencies, what will be the gain of the system? The ultimate magnitude of the system, of the compensator?
Minus 20 log K.
Minus 20 log alpha. Okay, this is basically what we have. How about the angle? How about the angle?
At infinity, it will go to 0.
It will go 0. It will diminish. Okay, and this is the trick which we are going to use. Okay, now the philosophy basically in this graph. Suppose I have a system. The black one is a compensated system. Okay, this is the magnitude and this is the phase. Okay, now the phase of the system, the phase margin 20. So if I want to use the phase lead, I might need, it will be a little bit difficult. Let's use the phase lag. So the phase lag, basically what we will do, we will, suppose I need, let's say phase margin, desired phase margin of, let's say, I need 45. The desired phase margin is 45. And let's put a safety factor with it, 5. So I need 50 phase margin. What we will do in here in the in this procedure, we will look for the phase margin of 50. If the phase margin is 50, what is the phase of the system? Can you tell me? If the phase margin is 50, what will be the phase of the system?
minus 130.
Minus 130, great. So I will come at minus 130, I will look into this point. And I want to consider this is my phase margin. Look, if I want to consider this is as my phase margin, what will happen in here? If this is the phase margin, it means that this point should go to 0, isn't it?
Yes.
So basically, I should take out from the system this gain to force the plot, the body plot, to go to 0, because I want, this is my phase margin. Okay, so what we will do, okay, this 20, I will take it by adding, look, remember this is the magnitude in here is minus 20 log alpha. So this is, you know, then clearly from here, I can determine alpha, which will have the effect of minus 20 dB. That's basically if the compensator will give me minus 20 dB, added to the 20 dB, so you are forcing this to go to 0. Is it clear? Any question here? Shabab,
No, it's clear.
how physically, how many of you are in here? In the other class, when I ask, you know, unfortunately, many of the students, they just, you know, they just want to put their name as, you know, attending, but I don't know what's the philosophy. But anyway.
معاك يا دكتور، بس والله مع الصيام الواحد
لا بس يا ابني مع الصيام ما شاء الله. لوك يعني احنا مؤمنين مسلمين صائمين ما شاء الله مصلين، ولكن من تجي الحاجات الاخرى يعني نتساهل بالامور. يعني ما تعتقد انه إن الطالب يخلي اسمه او يعني كانه موجود وهو ما موجود. هذا ايش تعتبره؟ هذا اي نوع من العبادات هذا؟
لا انا قصدي يا دكتور يعني احنا موجودين معاك، بس انه بعض ما يمدينا نجاوب.
صحيح. لا انا ما بقول، بس انه للاسف يا ابني يعني the other class على الاقل I called 3 people and they were not there. بطلت يعني if يعني if they don't care I don't care. It's unfortunate. I'm not accusing كل الناس، لا. Definitely في many of you are you know, but definitely Ramadan also يعني it has its effect. But what I'm saying I mean ما تجاوب this is something but ما يعني انت سجل نفسك حاضر وانت ما انت حاضر. This is يعني this is الاشكال. Anyway, so if I insert this compensator, I will insert the magnitude and the phase as well. So if I position the phase in here, okay, if I position this portion in here, it means that I'm going to take certain phases from the system, and that basically who asked me this question?
It's the phase margin.
Yes, margin. Definitely, then I'm going to affect the phase margin. So what they have done, rather than positioning the compensator here, they position it 1 decade before this. They position somewhere in here. Look, if you position the compensator in here, the phase in this area is going to be affected. But the phase in here, do you think it will be affected?
Minimum effect.
What?
Minimum effect.
Minimum, because look, 1 decade after, you know, the phase already diminished, while the gain is still, you know, minus 20 log alpha. So this is the whole point. In this design, you read the phase margin from your system. Okay, insert a compensator which will take the gain and position it far away so that the phase margin is not going to be affected by inserting the compensator. And this is basically the philosophy of the lag compensator. Sometimes we call it, you know, we do gain attenuation. we are doing gain attenuation. That basically I will take a gain from this area. Okay. Any question before we proceed to an example? If no question, let's, okay. Before the example, this is a procedure. The steps in the design. First of all, determine K, which will satisfy steady state error, which is the same thing which we have done before. Draw the phase, draw the body diagram for the uncompensated system with the correction or in the gain only. Okay, find the crossover frequency from the uncompensated system open loop body diagram where the phase margin is satisfied from the graph of the uncompensated system. Calculate the magnitude at this frequency, then find alpha. Alpha equal to, this is the magnitude, minus 20 log alpha, okay. So alpha is going to be, you can find it from here. Then we said in the design, I need alpha and I need tau. Tau will be determined by taking the zero, you position it 1 decade before the corner frequency, before the, new gain crossover frequency. Take this one, divide by 10, and that will give you the 0, which is 1 over tau. So tau is now known. Alpha is known, then the pole is going to be 1 over alpha tau. Okay, and then you will be done. Any question in those steps? Let's take an example. Okay, given the system, P of S equal 1 over S, S plus 1, S plus 2, with the body diagram in here. We want the velocity error constant to be 5 and phase margin of 40. Okay, look at this system. The gain margin 15 and the phase margin is 53. But let's see, is this system satisfying the steady state error? Okay, since we are going to insert, so there is no K in here, but let's use the K of compensator. Remember the compensator, this is the formula for the compensator. So if I insert the compensator with the process, then KV equal to limit S goes to 0 of S GC of S P of S, which is equal to, okay, what does this equal to? Can you tell me?
It is K alpha 1 plus tau s
K alpha,
multiplied by 1 plus tau s.
K alpha times 1 over 2, isn't it? That's it. And this must be equal to 20. So
Yes, yes.
So K alpha must be equal to 5, 10, sorry. So let's use this 10 in here and get the new body plot. Because we said the first thing we do in the design is to satisfy the, steady state error. Okay, if we do the body plot for the system by adding the gain of the 10, look what will happen. The system become unstable. Okay? The system become unstable. Okay?
The uncompensated system is going to be unstable.
If
Uncompensated system will be
no,
unstable.
this is the system by adjusting the steady state error. So basically, look, we have two things. We have steady state error we want to satisfy, and we have phase margin. What we said in the design, the first thing we do, we satisfy the steady state error. Okay? Then we make the plots. Clearly, by changing the gain, we run into the problem of instability. Now we will do the design such that we will get the desired gain margin. Okay, sorry, phase margin. Okay, now let me ask you, with this phase margin, can I use phase lead compensator? Abdurrahman, I do not hear you. Are you around?
Because we cannot use the compensator
We cannot. Why not?
because it is already the phase is negative.
Yes, but we can, with the phase lead, we will be adding phase to the system.
Yes, Doctor, phase lead can be used.
Can be used?
Why not?
Doctor.
Not really. Why not? Can some?
Because it's maximum 30 degree.
Exactly. Thank you. Because look, now in here, the phase margin is -13. And the required is what? The required is about 50. So you need, you have to add at least 60 or 65. In that case, even if you add it, it's going to be, you are almost in the instability region. Or it cannot physically, no, sorry, not instability. Physically, the compensator, we said, if maximum will give you between 60 and 65. Okay, so you are on the verge of it. So it's better to go to the, phase lag compensator. Phase lead, it will be, the system physically cannot provide you unless you use two stages of phase lead.
بس يا دكتور الحين مش الفيز لاج will take from the phase.
Yes, we take from the phase, but this is what I have said in the previous few moments ago. We don't position in the same place. We position 1 decade before, and I will come to it and explain it again. Okay, so now what is required? The phase margin, we need phase margin of greater than 40. Okay, let's take with it, let's say, a safety factor of 10, let's say. So I need phase margin of basically 50. Where is this phase margin in the, what's correspond to? What's the phase, what is the phase, okay. Sorry, this is P or whatever. P.
130 minus 130.
Exactly. So basically, it will be at 130. This is the phase margin, what I want, which happen at, so what's the frequency? What's the frequency? The frequency is about 5. This is, sorry.
No, 0.3.
Okay, 0.2, 0.3, 0.4, about 0.5.
Yes.
And the gain, what is the gain? This is the gain, which is around 20. So what I have to do in order for me to make this is my new phase margin, So I must force this system to go to 0 at this point. So I must take at this point 20 dB from the system. How do I take it? By
Make alpha equal to 10.
كيف?
Equate alpha to 10.
Yes, by adding, look, by adding the compensator, because in the compensator, we will take minus 20 log alpha. So we'll take this one and we can figure out what's alpha, which will do the job for us. But taking the
will alpha is 10.
كيف? In this case, yes, alpha is going to be 10. Okay. So when you take the gain, you are adding phase. If you position it in here, definitely this is not going to be your phase margin, because look, this is negative. It will take also from it. So what do? We position it somewhere in here before the negative is going to take from this area, not this area. Okay.
Doctor, but this way, the cutoff frequency will change.
What?
The cutoff frequency will change.
No, look, the body plots in this area will be changed. However, in this area will remain the same. And remember, we have said this when we introduce the system, either we change the lower end of the frequency and keep the upper end, and this is the situation here. Okay.
Okay.
I answer your question?
Yes.
دكتور في
تفضل.
سؤال. Why we position the compensator 1 decade before?
Yeah, Abdurrahman, let me go back. This is the characteristic of the compensator. Because the Y, again, let me go, okay. Look, the pole is before the 0. Okay. So the body plot for this one, I start with constant until the pole, then the body plot is going to go by minus 20 dB per decade. Do you agree?
Yes.
Then when I reach the 0 will give me 20 dB per decade with the minus, so I will have flat. And this is the flat equal to 20 dB, 20 log alpha. So it's going to be, basically it's minus. So if I add this one to the system, I'm going to take gain from the system. Do you agree? Because this is negative gain, and in there you have positive, you add them together.
تمام.
Okay. At the same time, the phase also is negative. But look at the behavior of the phase. At the lower frequencies, what's the angle?
It is almost 0.
0. Then it will increase, and this is the maximum, and we find the maximum. Then it will decrease again, and it reach also at higher frequency. What will happen?
The same, 0.
It will be 0. So what they have done, they use this property when I use the phase lag compensator. Okay, the gain, it doesn't matter where I position the gain, because always, you know, at the high frequency, it will give me minus 20 log alpha. But the okay, the phase will be 0. That's why, okay, if you come in here, if I position it in here, I have problem. So I position it before. So what will happen in the phase at this area? What will be the effect of the compensator on this area?
It will be very small effect here.
Very small effect. And that's what we want to do. This is not important to me. In this area, it's not important to me, the phase. What I want to keep the phase margin and beyond the phase margin. So I alter everything before I come to the phase margin to, for the satisfactory phase margin, and then the rest of it will remain the same. So this is why they positioned one decade before, because the effect of the angle 1 decade after, it will be diminished. Okay, is that clear now?
تمام يا دكتور.
Okay, now as I said, in this, let me repeat it. So basically, I need a phase margin of 40. I will add, you know, the safety factor of 10, so that it will give me minus 130. I will read. Okay, and that's happened at 0.5. So the 0, I'll position it 1 decade before. So 1 decade, it means that at 0.05. Okay, or tau equal 1 over omega, 1 over the 0, which is equal to 20. Now I need the alpha. The alpha, we said, alpha should be, okay, I should take gain of minus 20 dB from the system. So alpha equal to 10 to the power minus q over 20, and q itself is negative. So this will give me alpha will be 10. Once I have alpha and I have tau, then, you know, I'm done with the design, because, okay, because I can find the, remember we said omega z, omega z is equal 1 over tau. And this is, we take it 1 over 10 omega crossover frequency, the new crossover frequency. Now, the omega p equal 1 over alpha tau. So tau equal 20 and alpha equal to 10. So you are done. And that's where this is the 0, and this is the pole of the system. Okay, so basically, this is what I'm going to have. Okay, this is the compensator and the system together. Okay, now let me put the compensated and the uncompensated system together and see the difference. The compensated is the green and the uncompensated is the blue. Okay, so look what happened. In the lower end in here, I changed in the body plot of the system, while at the upper, at the higher frequencies, the compensated and the uncompensated, they are exactly the same. And remember, we said at the beginning, we will have certain situation in which we change the lower frequencies while leaving the upper unchanged. And this is basically what we have done in here. Okay, this is what we have said, and this is the exact example. Any question here? Any question, Shabab?
دكتور الحين لو حسبنا الفيز مارجن it will be 40, right?
Exactly. Will be أعتقد, yeah, 40, or maybe look, يعني very close to the 40. Let me go. Okay, look, yeah, the phase margin 47.5, which is, you know, more or less what we have, you know.
And now even the gain margin is positive, right?
Oh, definitely, definitely. Okay, we stabilize the system. Okay. So look, in here, maybe the design is easier because once you decide on the phase margin, where do you want to have your phase margin, you can read the frequency. Take 1 decade before that one, that will give you the zero of the compensator. So you left with only the pole, which is basically you can get it from alpha. So maybe this is, you know, and in this design, this is a little bit easier. Any question? Okay, let's take one more example. Okay. Suppose you have given a system g of s equal k over s, s plus 10 to power 2, with this is the body diagram. And we need the static error of 20 and a damping factor of 0.65.
damping factor قصته الزيتا يا دكتور ولا كيف؟
Zeta, exactly. Okay. So, how do we proceed?
Start with the error.
Okay, we start with the error. And then?
Limit as s goes to 0.
Okay.
For the compensator multiplied by g of s.
كيف say that, Abdurrahman, again?
Limit as s goes to 0.
Yes. Basically, okay, so for KV, to find KV, limit s goes to 0 of, you know, GC, okay, G of S, which is equal to, okay, if you,
هي اس يا دكتور ولا؟
0 is going to be K alpha
دكتور
compensator, and the, let me call it K1 and K in here
Or do you hear me?
over 100.
نضرب اس ولا ما نضرب اس؟
نضرب ايش؟
اس
Yes, that when انا ضربت باس، الاس will go and you will have
تمام
only be 100.
اي بس انك ما كتبتها فوق بس في الفورمولا.
I did not because, you know, I mean, I assume by now we can go quickly.
You assume a lot.
Okay, this is equal to 20. So the whole gain, let me call the whole gain equal to what? 2,000. I need a gain of 2,000.
Yes, clear.
So this gain will do the error, adjust the error. Now, what else I need to satisfy?
The
Phase
zeta.
margin.
The phase margin. What's the phase margin?
Says 0.01 phase margin equals zeta.
So the phase margin equal to what?
No, zeta is equal to 0.01 phase margin, I think.
No. Yeah, zeta equal point. No, this is 100 times zeta.
Yeah, 100 times zeta.
So this is going to be 65. The phase margin which I want 65. Okay. Okay, to start with, what is the, you know, phase margin of the system? What's the phase margin of the original system?
دكتور
Yes.
zeta here the system here best it's not a second order system. So the value of zeta I know it is
Well, assume, look, we always assume the second order is dominant, okay? And we consider it, okay? So we assume it is dominant. This is basically what we mean. the dominance effect of the system. Okay.
Okay.
It is so whether they are giving you the so you are approximating your system by a second order system. And in this case, I mean, it will be given in terms of zeta. So zeta, okay, or somehow they find the zeta for third order, but usually it is, it's approximation of the second order system. So the question is, again, to my question, what's the original phase margin of the system?
Original, so you have minus 180 plus 65.
No? Is it
Oh,
a little bit more? Okay. So it is negative. Okay, it is negative. So as I said, again, by having the least compensator, it will be extremely tough.
the desired one, يعني, we start minus 180 plus 65, determine the.
Exactly. So look, if this is 65, okay, we take again a safety factor, let's say 5 plus 5, that will be 7.
minus 110 يعني.
And minus 110, which is this one, this point.
سؤال يا دكتور معلش 100 زيتا هذه من وين جبناها ولا هذه well known information؟
Which one?
انه الفيز مارجن 100 زيتا.
عبد الرحمن شكلك الايام هذا مشغول يعني الكورسات كلها وتمشي بعض المحاضرات. If you go back الى
لا تمام اذا هي information يعني just
no
information.
لا it is we related. No, if you go you derive it has been already been derived.
ممتاز.
This is approximation. Okay, this is
ممتاز.
it is for the I mean, look, we are using it, yes, for second order. It's true for this formula, it's for second order system, but what we are assuming that the second order is dominating. Okay,
Yes, this is why I asked, because now we have a third order system.
yes, but we assume that we are approximating. Okay, so now this is the phase margin, so I should look into this point. And then I go up. First of all, what will be the, frequency? What will be the new crossover frequency? So, what will be the, what will be? So basically what we want to force this one and bring it to 0. So I need to take out from the system 24 dB. At which frequency?
Around 1.
1.5. Okay. So basically, I will have my new crossover frequency equal to 1.5. So where do I position my 0? Where do I position my 0 of the compensator?
Just divide by 10 يعني 0.15.
Okay, exactly. So omega z equal to, okay, 1/10 omega c1, which is equal to 0.15. This is where I will position my, and this will give me, okay, definitely I can get, this is, tau equal to 1/0.15. Now the alpha, we said I want to take out 24 dB. So alpha will be what? Alpha equal to 10 to power, okay, 24/20, and whatever that value is going to be. And I am done. Okay, this fifth factor we said 110.
يعني دكتور it's a technique that you follow without يعني thinking ولا شيء.
If
I'm saying it's a technique that you follow without thinking يعني it is a strategy.
it is no, it's a procedure. They are giving you procedure. Okay. This is procedure which we are using. So once you know the procedure, it becomes, easy. As I said, this is basically what we are going to have. This is our compensator, or in the frequency domain. The procedure is, from experience. Look, remember we said, when we talk about design, there is no unique way of doing it. Everybody will do his own design. For example, in the 70s, when the oil prices were very cheap, nobody cares about the shape of the cars in terms of the resistance for the air and how much gasoline the car will consume. But when the prices become high, the people start thinking, and they have to worry about the aerodynamic of the car. So they came up with so many designs, and each one has its own advantage and disadvantage. So the design is not unique. We are following the this is, since we know, this is similar to, you are going from here to Riyadh, the whole area. Okay, when you go so many times, you memorize the whole way. So this is the same thing in here. We are putting the procedure, and we're following the procedure. Okay, similar to look, when this is always, when you do the root locus, what did you do? We gave set of rules. You use them. Okay, same thing in here. I don't know, Abdurrahman, did I answer you, or is that what?
Yes, you answer me.
Okay. Any other question?
طيب يا دكتور، الحين احنا خلصنا الفيز ليد والفيز
Phase lag.
لاج.
Okay.
Now we will move
From
to the
body
next one.
plot, from body diagram. What we do next, next lecture, we will discuss the phase lead using, root locus. Unfortunately, the phase lag, we don't have time, but we should continue with that. So,
And you will discuss the two types from the body diagram perspective, and then the first one, which is the phase lead from the root locus perspective, and that's it.
that's correct. That's correct. That's correct. Because of the limitation in time. And, it's, I have noticed that, giving the lecture over on the online is slower than, in phase. Okay. When we are face to face. Okay. So, I remember when we used to have before the COVID-19, we do cover the phase lag using root locus, the PID as well. But lead lag, usually we don't have time. Lead lag compensator, usually we don't have time. Okay?
دكتور الديزاين داخل في الفاينل اكزام؟
بالتأكيد. أكيد.
ايش قاعدين نضيع وقتنا يعني ولا ايش؟
والله عشان اقول جزء منه مو معانا فتوقعت يعني.
No, definitely. يعني بس
لو ما هو داخل.
Look, بس it's not going to be, if the question will come, I don't think it will be complicated. Okay, no challenge.
Just a little bit complicated.
Just little bit. Okay. Any other question? Okay, I think we'll stop in here.
الله يعطيك العافية دكتور.
الله يعافيك.
Thank you, Dixon.